So hey guys, welcome back to the channel, and in this video we are going to start with two sum problem and two pointer method. So let's get started. So before we get started with the two sum problem, we should understand the concept of pointers in algorithms. Okay, this pointer is not same as your C pointer or your C++ pointer. It is a very easy concept and relatively easy concept compared to that. Okay. So if I say what is a pointer? Yeah. So we'll start with what is a pointer. Okay. Any variable slash reference which points to a particular spot and a list or in general say a data structure. So any variable or reference that points a particular spot in a list or in a data structure is actually considered as a pointer. Okay, great. What's the example? How we can say? The most basic example which you have seen till now and you have done it in the programming, that is printing numbers from it. Printing numbers from array. If you have an array, okay, if you have an array, what you actually do? You actually use a for loop, okay, for loop slash while loop, okay. You use variable I, j or k, whatever, and then you print, and then you increment. So if you carefully see, these I, j, and k are actually having physical significance. They are moving over the array, providing you with the particular index. Like I is equal to 0, then I is equal to 1, I is equal to 2, I is equal to 3. So they are actually providing you with the index. Now, they are providing you with the index, and then you are using that index to actually print the values from the array. Great. So you can see in a sense that this I, j, and k is actually kind of a pointer which is moving over the array, pointing to each memory block in the array. And that's the most basic example you can have for a pointer. Okay. So yeah, great. Now let's see another example. Okay. Let's say I have an array. Okay. Let's say I have an array. Forget about two sum problem right now. Okay. Don't confuse this problem with the two sum problem. I'm going to take it later on. So let's say I have an array. Okay. I have any array. Let's say here I have some value. Let's say 5, then let's say 2, then 3, then 11, then let's say 9. And I need to find some value x such that you can say, let's say I take the value of x as 13, and the condition which I need to fulfill is that I need to find two numbers two numbers from array which sums to x. That means that if you two, let's say two numbers from array, let's say that number is counted by I and plus there are some j, then this sum should be equal to x. That is what I need to fulfill. I need to find two such numbers. So what will you do? You will say, okay, I need to find two numbers. So I will check all the combinations. So how I am going to check all the combinations? I'm going to take I here and I'm going to take j here. And I'm going to run the j from, it says I is at the initial position. I'm going to run the j from the next position, uh, from I plus 1 till the end. Then I'm going to move I to here, and then I'm going to run j from here to here. And this process goes on and on and on and on until you really find some satisfactory results. Okay, you can't do this thing. Okay, so running these two pointers, this I and j is actually pointers which you are using to solve this problem of finding some. Okay, you are doing this. Think about the time complexity. What is the time complexity of the above mentioned solution which we have seen? So if I is equal to 0, steps which you will take for j, steps of j. What are the steps taken by j? Or how much steps are taken by j? You are starting from I is equal to 0 and j will start from I is equal to I plus 1. Then j will start from 1 till the end. That means j is going to cover n minus 1 steps. Similarly, I is equal to 1 will result into steps n minus 2. I is equal to 2 will result in steps n minus 3. And this goes on and on. I is equal to n minus 2. Then j will take steps. Steps, you will be having only one step. And that is what is going to be the situation. It's going to go from n minus 1 to 1. Okay, great. In the worst case, so total steps will be n minus 1 plus n minus 2 plus n minus 3 dot 2 plus 1, 3 to 1. Okay. So what is this sum? This sum is actually n minus 1 n by 2. If you don't know like the first sum of first natural numbers, it's actually this. Okay. So these are the total steps. These are the total steps. Okay. So what is the time complexity? Time complexity is actually big of number of steps taken. Steps taken. Okay. So what will be that? Will be O of n minus 1 into n by 2. Solving it further. Okay. So what will it be? It will be n square minus 2 by 2, and that will be O of square by 2 minus n by 2. Now removing the less significant values, it will lead me to O of n square. O of n square. This is what I am left with. So this is these are the like number of this is the time complexity. So what is the actual time? What is the actual time? So actual time is calculated by you multiplying the number of steps, or you can say you multiplying this with the constant time, that is n square into e, and this constant time depends on the system, so you don't actually need to worry about that. Okay, what is the space complexity? Space complexity. So space complexity is the extra space taken by the algorithm to solve the problem. Only I and j are used and they take constant space because they are constants. So they are going to have this algorithm have of one time complexity. Or in like broader sense, you can say like O of one plus one. One the first one is for the I, second one is for the J, and that rounds up to only one. So this is this one. So how you write this algorithm? You can write it like this for and I equal to zero, I less than n minus one, I plus plus, I actually goes up to n minus two. Then you can like for and j equals I plus one, j less than n, j plus plus, then if arr I plus arr j equals to x found. Okay, so that's for the first algorithm, and this is how you are going to implement the algorithm. Okay, so I have quickly solved the problem here. You might feel like this a bit overwhelming. Uh, okay, I have solved it pretty fast, and you might not be able to catch that up. But if you see it again, you will understand that this nothing. This is what you have done earlier also. It's nothing new. Here, the j is moving from 1 to n minus 1. That's why it's taking n minus 1 steps. Okay, for the first um, you can say first set. Then for the next set, the j is going to take n minus 2 steps, and steps are going to gradually decrease. There's nothing special here. I've used like the normal method of like solving things. Okay, so we have seen a kind of brute force. So this was all a brute force. So what is the now we have seen? Okay, this is kind of the method we are like looking towards. That so we are going to use like this two pointer method, but in a more appropriate manner. So to say that, I'm going to have a question that is given a sorted array, given a sorted array, find two numbers, find two numbers which sum sums up to target value. Target value. Okay. So let's say if you are given array 2, 7, 15, 30, and 100. This is given to you. And let's say x equal 37. So you have this. Now what you need to do is you need to find two numbers from the array, from a sorted array. Okay. You need to find two numbers which are going to sum up to 37. Okay. So you can either use the previous method which we have seen, that taking an I, taking a j, moving, checking all the combinations, and you will end up finding like you can say you will find ultimately a set of numbers which sums up to 37. Okay, but we are not going to use that approach. Why? Because that algorithm is taking O of n square, which is not a good time complexity. Let's improve it. Okay, so Instead of starting from I here and J here, can I do something else? And yes, there is something else. This is that something else. It's taking I at the first, J at the last. Okay. So what will you do? Forget about the target value. Okay. Just like dry run this thing with me and you will understand what I'm saying. I is here and J is here. Now let's add the values at I and J. I is having like 2 and J is actually pointing to 100. So what does sums up to? It's 102. Great. Let's move I to next point. Okay. It's now it's 7. Now J is 100. So what it will sums up to? It's 107. Great. Let's move I again here. Now I is pointing to 15. Now what it is? 115. Okay. Let's move J back. Now J is pointing to 30 here. So now what it is? Now the sum is actually 45. And you can see that when I am moving, when I am moving I forward, the value is increasing, and when I am moving J backward, the value is decreasing. And we are going to expect this same property. Okay. So as we have seen, the array is actually sorted. And by the way, this thing will work only in the sorted array. It will not work in the unsorted array. Because when you move I forward, it's going to take a bigger value. And it is that bigger value will add to the like J and give us a bigger number than the previous sum. So that's why it works only in the sorted arrays. Either decreasing or increasing, it doesn't matter. Okay. So as we have seen, it is 15, 30, and 100, and our target value is this. So we can take I here, J here, and you can say like we will adjust our sum. Sum is actually I plus J. The sum is actually I plus J, and we will adjust it. How? If the sum, if the current sum, let's say current sum, if current sum fall behind 37, let's say current sum is less than 27, then what we are going to do, we are going to increase the I. As we have seen that increasing I increases the in, increase I, current sum will increase. If current sum is greater than 27, J minus minus, okay, that means decreasing J, current sum will decrease. Okay, so if you say that, okay, first you have 102, then if you keep on doing this thing, you will end up finding 37 as the sum. So now we will see that why we have done what we have done. Why we have taken the approach of like moving I and J from the extreme points towards the midpoint. Why we have done that? Obviously, it was to improve the time complexity. So you question, okay, does the time complexity actually increased? And yes, it does. If we have a sorted array and this is I and this is J, and if it moves, if I moves and if I moves from here and J moves from here, okay. So what is the best case? Best case that wherever you took your I and wherever you took your J, The first sum actually itself was equals to x. So in that case, the best time complexity is 1. Then we have average case time complexity. That means that your I approximately have traveled n by 2 steps and j approximately have traveled n by 2 steps. So your average case is actually will be steps traveled by I, the steps still traveled by this, and that will be O of n. Okay. Here I actually took like n by 2 steps and j actually took n by 2 steps. We are considering for the average case that our sum or our like the numbers which we were finding were about in the middle, and that's why it is um, obvious that I is going to travel around n by 2 steps and u is going to take around n by 2 steps. It can be n by 3, it can be n by 4, it doesn't matter. But yes, because constant values doesn't matter. Well, now, the best part. What's the worst case? Even in the worst case, even in the worst case, the J will travel from the first extreme to the last extreme, or I is going to travel from the first extreme to the last extreme. Okay, so even in that case, I is going to take around n minus 1 steps, and J is going to take around n minus 1 step, that is traversing whole array. So in that case, it's going to take around n minus 1 steps, and that will end up with n, big of n. Now you know that big of n square n is like great. You can say like it is like a bigger time complexity as compared to of n, or you can say that big of n is better. This is better than this. And this is bad. And this is better. Okay. So you see that we have actually improved with the time complexity. What about the space complexity? Space, right, space complexity. That is bigger of one only. Great. So as we have seen all the analysis of this algorithm, we can write up the code. So this is the code part. Okay. So this is a generic code. You can apply it anywhere. I'm going to take I is less than j because I don't want overlapping. If I and j points to the same number, then the whole point will like get destroyed. I actually want that I and j actually points to two different numbers. This is I and this is j. Then we will see if ARR I plus ARR j is equals to x, then found. Okay, as ARR I plus ARR j is less than x, then we are going to increase the I, and else we are going to increase the no, we are going to decrease the j. Okay, we are going to decrease the j. Okay, so that's the algorithm for the two sum problem. Great. You might having a like few doubts here and there, please watch this video again. Dry run few of the things which I have said, like move I forward and J backward on your own and check whether the sum actually increases or decreases. Okay, dry run it, you will understand a lot. So that's all for this video. We have seen like a lot of thing in this video and she actually understood a lot. So yeah, if you like this video, subscribe. You can like on the bell icon and you can like this video, share it with your friends, share it on the socials if you want, like take up the screenshot of this session and share it with on your socials. It will be great. And yeah, stay tuned for more videos. And I'm going to make more such videos on like very good problems. And a lot of material is going to come up in the future. So stay tuned and yeah, bye.
Take me back to a place where I felt at home. Take me back to a day when we weren't alone. Take me back to an age when the world felt small. Way back before we blew it